right, so we are on learning objective 10, which is to use Bohr's model of the atom to explain hydrogen's emission spectra. So Bohr proposed that the hydrogen's lone electron was only allowed certain energy states or orbits, which he called the principal quantum number, which is abbreviated as N. There are two states that the electron can be in. You've got the excited state, which is when the electron jumps to a higher energy level. Again, this higher energy level is the principal quantum number N. Okay. And then you have the ground state, which is the lowest energy level for the electron. So again, Bohr proposed that hydrogen's lone electron was allowed certain energy states or orbits, which he called the principal quantum number, which is abbreviated as N. There are two states that the electron can be in. So again, this is just for the hydrogen atom, right? It can be excited, which is when the electron jumps to a higher energy level. And then you have the ground state, which is the lowest energy level for the electron of hydrogen. Now, we've already talked a lot about this, but this is how you would explain how an atom emits certain colors of light. Okay, so when energy, this can be in the form of heat or light. You could even do electricity there. When energy is absorbed, the electron jumps to a higher energy level or becomes excited, or the excited state. As the electron falls back to the ground state, the electron emits energy in the form of photons of a certain color. So this is how we get that color of light that comes off. Remember, photons, this is light. So let's say this is hydrogen. So hydrogen's ground state would have one electron right there. So that is the ground state. That's what we would consider the ground state. This is the lowest energy. As light comes into, energy comes into the atom, so we get energy. This electron jumps to a higher state. Now, depending on where the electron jumps, whether it's n equals 1 or n equals 2 to 5 or 6 or whatever, we would get different colors of light coming off. So as the electron kind of falls back down, so my red color would be falling back from n equals 3 to n equals 2. This produces the red light that we see. You get kind of a blue-green light when it falls from n equals 4 to n equals 2. We get a purple light from here to here. And then we get this really, really hard to see violet light. So again, when energy is absorbed, it jumps to a high excited state. And then as the electron starts to fall back down to its ground state, that's where we get the light color released. So that is, now notice with the hydrogen, you only see when it falls back down to n equals 2. That's still an excited state for hydrogen, but we can't see the actual color for that. So the only colors that we see are when it falls back down to n equals 2.